Welcome to Func Prog Sweden, everyone. Great, we are back. First, welcome everyone here and all recurring viewers and all recurring participants in the live event today at Kivra, and also welcome everyone that joins on the live stream. Agenda for today, I'll do a short introduction first, and then we'll head over to Peter and his presentation, EYG, a predictable and useful programming language. Not the others are not that useful, hence, yeah, you understand. First, I would like to thank Kivra, our venue sponsor. Thank you very much for letting us know coming here. Yeah. And also thanks to the great soup. Not like pizza. Woo! Then also, thank you very much, The Beat, for sponsoring the video stream. And the coming schedule then, 5th of November, we'll be back. And then 3rd of December, and then we haven't set the date yet for January. So if you have a presentation, you want something, present something, suggest a date before we set it. And of course, you want to support the community, and you do that by heading over to Meetup and joining, and to YouTube and subscribing. Last but not least, there is a Discord channel if you want to ask more elaborate questions, because yes, it's tricky to ask questions in the YouTube chat. You're not allowed to ask more than, I think, 120 characters, something like that. And if you have questions here in the room, now I'll go out the picture. Please, I'll send the mic around so you can use the mic. And if you have questions online, shoot in the chat or in the Discord. With that, let's get started. And welcome Peter Saxton to Func Prog Sweden.
Thank you. Hi, everyone. Yeah.
The stage is yours.
Cheers.
Yeah.
All right. So this should be over here. Should be. And we don't have it up here. Now we do. OK. And I think we were going to make that. Is that big enough? Yeah, it looks good enough. OK, so this is my talk about EYG. So I'm Peter. I've been talking to a lot of people about Gleam recently. I'm a big functional programming nerd in a variety of ways, but this one's going to be different. And this is my language. This is a bit of a kind of, there's going to be a bit of a thesis on what I think makes something useful and what's important. So this is, you've got to have 3 words when you start a new language. So we've got predictable, useful, and I added confident because I had a bit more time to think about it. And so predictable programs are all deterministic. Dependencies are immutable. This is kind of a bit of a bread and butter for improving your productivity in functional programming, which is where then I lead to the second point, useful. So run anywhere, manage effects, allow you to declare runtime requirements. Like your classic pains with functional programming, a lot of stuff around monad complexity. I'll try and sort of talk about how I've addressed some of those. And then confident, this is fairly common in the functional space, but the type system is totally sound, i.e. if it compiles, there's no runtime bugs. OK, so let's have a quick go at what it looks like. So we'll go a bit more detail into some of what's going on here, but I just wanted to kind of get started with an example. So this is some EYG script. We have effects, which are these perform keywords. And this is telling me that it needs to do an effect. So one of the nice things about effects is you can resume the program. So it's asking for a prompt. So if I click this, I go, yeah, what's your name? And you go, Peter. Great. So no, I didn't think this doesn't work full screen. But what I've got here is I've got download. So one of the effects is I can download code. And this client function is going to run in the downloaded page. So over here, I've got hello, Peter, as a program in a different page. So this is one of the things that we'll get to for how this works. And so having a new tab has already messed up my shortcut for which one is where. So full screen here. OK. And then the other thing we sort of talked about, these immutable references. So here we go. Here's another program. This library here, this hash, references some code that's available in the cloud or on my local disk. And it has an HTTP library in it. So if I run this one. We hit this catfact.ninja API. We get a fact. Cats have about 130,000 squares. Well, that's good to know. But one of the things we could do here is we could go around. We could, actually, we could delete a load of these things. But if we put in, say, the HTTP variable, and we run this, well, we don't actually need the fetch effect to happen, so let's delete that. The return value is this object, which has a bunch of functions wrapped up in a record. Okay, so that's the kind of like headlines of what we have. So if we go over here, right. So I'm just going to, really get some people some familiarity with what they're looking at here. One of the things I've skipped over is, so EYG, the language, doesn't have a syntax. This is, I actually think, not a particularly exciting choice in a lot of ways because the semantics are far more interesting. But yeah, so this editor you're looking at, this is a real runnable code example. Everything is structural. So if I press D, it deletes the unit in front of me. If I press N, I get a number, and it evaluates all the time. So this is now 17 at the bottom. And that total type system, so if we press S for a string, we go hello. Oh dear. We get a type mismatch down here. Cool. I suppose, yeah, another point was I am happy for questions at any point. So if people want to do that, you might have to interrupt me if I'm looking down here while I'm typing through. But yeah, so that's a fairly simple first one. Strings. OK, we've got strings here. There's a bunch of built-ins. So these are things which are available on every EYG implementation. So you press J, we get built-ins. It tells you all the types that are available. So here we've got all the built-ins that start with string. So we could uppercase it. Now we have an error going while we're passing two arguments. If we delete this one, we get hello uppercase. And so everything's, well, I say quicker. There's obviously other problems, but there's no way to create an invalid program in EYG if you use this editor. Every transformation is a valid structural program, even if it's not going to type check. So there's no missing colon, no extra comma. That's impossible to get. Lists, another useful thing. These are linked lists. We can add them together. We have get rid of this. We have tail extension. We just got this function where we're going to fold over the list of items and we add them together. So another bit of functional goodness. We have this full stop to extend lists. If we put v, this is the variables in scope. We need a list of items. Go back to 13. Compress and have more. Number 3. All evaluating as we go along. OK, so records. So this is where things start getting a little more interesting. One of the choices that EYG has made is that it's structural. So there is never any reason to declare a type in EYG. So a structural program means that the types are all defined on what's in the value that you're passing around. So the records here, both Alice and Bob are records with the field name. But obviously only Bob has the field height. And so as we go through here, we can come down to Alice, and we can edit this. We go, yeah, let's make this Bob. We get the name Bob. We can edit this. We get the name height. OK. So that's structural records. One of the important things about this is if you make a function, so let's say with a height, which is going to take in a height, we'll make it be the function greet. Well, OK, let's come back to that one. So this is now accepting anything with the field height. Probably I should have picked the other one for the demo, but we'll just get the height. Mistyped it. Yep, good. Thank you. This one now matches because we got the correct autocomplete. Oh my God, what am I spelling? There we go. Now it goes. OK, so because it's always type checking as we go through, we can click to this one. It goes, yep, press V. That's the only thing that matches. We should go through. Right. Oh, God. The order. The order shouldn't matter. So any record with a field height should work. Second? OK. well, anyway, so I think we'll finish this demo and we'll see what we get to. Greet. So if we greet, this is the height. So if we pass in Bob, cool. Bob's height is 192. If we pass in Alice, we get missing row height. So that's so everything is structural. Here we just have some syntax for overwriting fields. So this dot extend in the second example. You can only update fields that are existing on the initial record. You can't extend them to value types. This allows for efficient compilation. Just a little sort of factoid for that one. So then unions. Okay. So unions, tagged unions. These are again a kind of bread and butter for functional languages. Again, they're structural, so that they anything which has a anything with the members that you're going to match on can be passed in. So, for example, if you had this match statement here, so this int pass returns a result, so an OK or an error. We can go all the way in, and we can, I believe, add a new one. OK, and then this should, maybe I'm lying to you. OK, I didn't practice this demo. Let's see if this is true. Error. So there's a to-do down the bottom, but if we change this, we tag this with just OK. One of the nice things, again, because the types all pass around, when I'm being suggested, it tells you things that fit in this space. So this is something which must be an OK or an error. So if we pass in an OK value, OK, yeah. This is fine with the fact that the type doesn't include an error. Like the type of this value passed in is just an OK. There's no error type. There's no error variant that's possible. And again, just another feature which might be useful for some of the examples we have later is that the match statements here can be open. So this example, obviously, if we match on cat, we take out the name. But if we tag this with something else, this can be a, I don't know, bird. Okay, we hit the fallback case. So you have the ability to have open unions. Okay. Right. Functions. Functions are curried by default. Functions are first class. Again, I promised a functional language. I think we shouldn't be too surprised by this. Function declarations, well, I say they look like this. They could look like anything because there's no syntax, but you create one by pressing F. So I don't know, we can, we'll have a new one for you guys. Special. What should we do with this? We'll take an X, and we'll ink to, well, OK, fine. We can ink to twice, which we've already got. So it's not entirely exciting, but here you go. V, X is in scope. We've got special. I will explain why I was writing slides this morning. I'm sorry about that, but you can. 10. 104. So we've inked to twice to 100. OK. One, I guess, unusual feature with EYG is that recursion is an explicit fix built in. So here we have a count function. So this is counting the number of items in the list. If we add another item in the list, we have 2 items in the list. So what we have here is we have a recursive function. So this function has 3 arguments, count, total, and rest, where rest is the list that you pass in. The count function is the function itself. So this is how recursive functions work. This is how recursive functions work here. This is I can't remember exactly which name of combinator this is, but this is a very basic way to do things in a lambda calculus. OK. All right, and then we have one more, which is down here. So capture. This is this might be new. OK, so I want people to put hands up in the room, people who know what closure serialization is. No. Yes, 1. Cool. Right. This is, I think, going to be a thing that people talk about more because it's quite useful in infrastructure as code. So what this is doing here is we're capturing a function. Okay, so we're reserializing it back to source code. So the thing we have at the bottom here is the AST of an EYG program for this lambda function here. So if we change this and we say make this a string hello, this is a function that returns a string hello. One of the things that's kind of interesting about this is if we do message here, and we say string hello, and we go through, and if we delete this and we say message, okay, so this capture is now working out that it needs to define message. It needs to put that in. So the returned AST is something that is a let with a message block with the string hello, and then a lambda, which is scoped to include that. And if we go even further, so where this gets interesting is if we go foo, and we make foo a number like 10. If we scroll down here, foo is not captured. Okay, so it's efficient to do this. And one of the other sort of built-ins we've got is, oh dear, to JavaScript. Cool. So here we go. This is now, because we've got an AST we can handle, we are compiling a subset of the program, essentially the continuation lambda, into source code. This source code will run somewhere else. There's more than one way to serialize it. Like JavaScript is just an example I built first here. You can have the data structure for EYG, which is a big JSON blob at the moment. It's smart enough to know when you put in built-ins. So if we do here, let's do int. I'm sorry about that. Wide int add. Okay. So it's now smart enough to go, I know that I need to add that built-in. So int add is added here because we use it below. And again, if we call this with, say, the number 5, well, let's do 5. And then we make this the variable foo, which is in scope. OK, so now we're getting the built-in that we all need up front, the variables that are relevant to the function that we want to continue, and then a implementation of the function that we're building. OK. Questions time? Everyone's totally happy with this. We've explained everything about function serialization. Right. So, OK, well, we're gonna level it up a bit more. So we're going to talk about effects. So effects are the other thing that make EYG useful. So I say that this is useful because you can write a minimal amount of effects for an interesting place. So the example I showed right at the beginning only had the alert effect. That's the only thing that's available on the browser. And so where were we going to go with this one next? So I think let's talk about effects. I don't have, this is slightly old documentation. That's a bit smaller as well. Again, I'll have to, there's about 4 editors for this language. There's a small AST. This is meant to be a feature, but again, we can crack on through. So here we have some code. Here we're calling the brackets directly, and there's a standard library hash implicitly in scope. Otherwise, you're looking at the same programs. OK, so here we have an effect which says hello world. OK. I suppose this is a bit more common. Who's familiar with algebraic effects? There's got to be more than one. 4 or 5 people in the room. Languages like Coca, Unison, Rock, they're all kind of thinking that these might be a useful thing going forward. So effects are how you make your programs pure, essentially. So when you reach an effect in a program, the program runner suspends the program, the continuation, and you fall out to a handler to provide the rest of the computation, to provide the return value. So non-determinism, so here we have a flip. We run heads or tails. If we keep running it, we get a different one each time. One of the key things about effects is they start normalizing a lot of different features that other languages make kind of special cases. One of them is like aborting or throwing exceptions. So here we have this abort effect, which just aborts the run. Okay, so but the abort effect is no different than any other effect at this point. And all of these effects can be handled. So bear with me, I'm just going to grab some water. So if you're familiar with try-catch, that's where you handle exceptions. And again, we've just taken that principle and made it generic. So here, for example, we have this function down the bottom. So this is the main block here, these last 3 lines. We just have a program that's going to alert twice. Testing this is a real pain. We don't want it going off in the browser. If we test it locally in Node, we don't have the alert effect available. And so what we have here is we have the ability to handle the alert effect. So what you pass in is you pass in a handler, and then some exciting flashes, and then the function that you want to run. Okay. So here, when you handle an effect, probably be easier to put this in line, but the handler is given the thing that you were, the message you raised, the thing that was lifted, the thing that was thrown, is the best way to think of it, and then a function to go back where you were. So what this handler does is, when it gets a message, we just resume with this is unit, so like no value from the alert, it just returns with essentially nil. Okay, this is a big flash in the background. And we just add all those alert messages together. So when we run this program, there's no alerts. We've handled everything here. And if we were to just change this, so we were handling the effect. Oh, it doesn't like they. Okay. Yeah, as I mentioned, this is an editor I've not used a while. We're going to try this one more time, see if I can remember how it goes. What have we got? I think we've got log. Cool. Escape. Enter to run. Nope. Nope. Okay. I'm going to try one more time. I'm feeling good about this last one. So, the log. So I think to exit insert mode in this header, we press escape. Then it says down here, we press space to run. There we go. So we've got rid of that handler, so these effects are running their real effects again. Okay. Okay, and then, so I think effects are really useful. Like, there's a lot of things that just sort of go away. One of them is like the concept of kind of mocking, or even like some amount of like property testing, where you do odd things. This is one of my favorite examples. No, this one's not my favorite example. This one's my favorite example. This one's a rubbish example. Here we just take away the non-determinism. Here we return every possibility. So let's slow down and walk through this one. So this one gives us, right, here we go. So here we have our program at the bottom, which, so this choose function just goes up here to this perform choose. So it's expecting a true or false. It does that twice. So there's a first value, there's a second value. Okay, cool, and we return those. So if we return this without the handler, we would just get true or false twice in this list. The thing that's interesting about this is we handle here with this handler up here. So we don't care what's raised. Choose is an effect that you raise it with essentially nil or unit. There's no input, and you return true or false. The resume function is how we go back to the program. And in this example, we resume it with both true and false. And we append the list of these together. So we run every possibility of the program. So the result for this thing, this sort of meta program, is the program passed here to both with all possibilities of the choose effect explored. So your test suite, if you have some invariant guarantees and you have a bunch of Boolean logic, you can say this will never do something else. Okay, this is everything that your program can do. You can inspect, because the type system will tell you what effects the program raises. This is everything this program will do. Like, you've not solved the halting problem, because the halting problem talks about something else. But for your program, you know that it does not. Like, it terminates because you've enumerated every possible termination. Cool. Questions on effects? Nope. No, okay. He's really keen with the microphone. He's ready. He's on the guy. Yeah. Okay. So, right. Number 5. Who's ready to see if I can remember how to use a third editor? Okay. Right. So, I want to talk some more about like how this has been made useful quickly. So, the language, I made a lot of promises up front, and then I've shown you a bunch of like functional nerdery features going on. I suppose we're probably going to keep doing that. So here we have a syntax. I don't like that this exists, but I had to make it one time because it just had to happen at some point, right? So then we say, okay. So this is the source tree for this program. This is another view of the thing I was showing you previously in the capture. This shows you nicely how effects commute. So if you say like let f equals, we're going to make it a function which does nothing. This is now back. I have no help, right? I can make syntax errors all over the place, and none of you know the syntax to help me. So let's see how this goes. alert with a hey. We need to return, so let's return, say, 0. Okay, so now we've got more of the source stream. Okay, so we have calls here, we have perform, all the nodes going on. We have the inferred type of every single node in the tree, and we have inferred all the effects that are part of it. We also highlight the effects as they form. So here, if this program, this F program was to be used later, let's pass this F, this X to our F. Calling F, because it raises the alert effect, is, I don't know, what would you say? It's inherited. This is in many ways the function coloring problem, but again, general. So, all functions that call something that raise the alert effect will themselves raise the alert effect. It composes nicer than the function coloring problem because you have ways to get rid of it, because you can make await something that you don't allow in the effects of your top-level program, and then everything, you can basically rub out all those colors. Well, yes, to some degree. Okay. This is something I find incredibly useful. Like certainly when I debug, I don't know if you've had the problem where you've picked your nice functional language, say Gleam, say, I think the same is true in a lot of stuff like F#. Your kind of largest unknown is, does it hit the database again? Like there's a lot of advice around functional core and kind of imperative shell, but actually there's very few languages that force this to be true. I've written medium-sized programs with EYG, and this is a big deal breaker that you can just go, no, I've got an effect wrong here. We can also show you, because over here we have the compiled output. So we have a better view of that JavaScript we were talking about. So I think this is the thing which I will maybe not try and explain now without slides breaking this down. I can talk to you afterwards about this, or we can share a talk which explains how this works through. This is the paper from the people behind Coca. It's for this essentially type-based effect compilation. So if you squint, you can kind of see the program at the bottom here. So anytime there might be an effect, so here we were performing hey, we have to bind it with a continuation. So this _4 is a value that is like a program we continue, and then bind is, these are essentially a bunch of built-ins that are all added if an effect is thrown anywhere in the program. So the outcome of that original program we were looking at was something that looked like this. Cool. All right. Where were we going next? Where were we going next? Well, I think actually it would be nice to just show you the kind of first program again. So we had these two. I'll refresh these to make sure we're with the ones I expect. Okay. So, right. I threw this up very quickly. We've seen everything that makes the language. Okay. So I'll kind of just maybe talk through this one more time. So we don't rely on any hashes in this example. I wanted to separate them on the front page. Probably you would make this a bit slimmer. Like you can write a function which is concatenating strings rather than using string append twice. That's that's just to keep things very low level. This to JavaScript is built in, so it's something that the runtime provides. It's something I want to get rid of given enough time, and you can rely on the capture function because you could obviously write a JavaScript compiler in EYG, but that was too many levels of kind of like new technologies going on at the same time. Here we have this prompt effect. So prompt is the thing that pops up that asks you what's going on in the browser. This effect is only available in this space. I've put this in this editor. If you run this code somewhere else, you won't. You won't get to run the prompt effect. So the client. This is the continuation that is used later. The alert effect is actually available both in this context and in the compiled context. And then we have the page function, which is just, not page function, this is just a page value, which is just wrap this client function in a script. So with this client function is the closure, and so on and so forth. And then the kind of thing which maybe we skipped over is this name value is found on the build tool. So essentially what we have here is my build script, and the deployed artifact is the deployed artifact. So again, this is one of the claims about increasing productivity. When using EYG, you can have your client and your server in the same program. this could have, you could have a build script that's fully typed. You can have a deploy effect or a deploy function, which you pass in a server continuation. All of your configuration is passed by scope and strongly typed. Your server can then pass a continuation down to the client, all fully scoped from your original thing. And you can't accidentally pass a reference to the database to the client. Well, you can. You'll have it but you can't use it because you don't have a query database effect anywhere that you shouldn't have. Yeah. So this is my okay, we're now starting to get somewhere interesting. Let's run this one more time. I think we'll get. Yeah. Should we say, woo, Stockholm? And we have to. Yeah. Index 1, okay, we run, we go hello Stockholm. We can view the page source that was, and it looks a lot like everything that we saw earlier. And here's the program with Stockholm kept as a value that we passed through. Okay. So, all right, yeah. Cool. So we have, I think, right. So I have one more thing, which is like the option to show you, which I think would be nice to see. So now we're on some JavaScript code. Let's get rid of this. So the EYG language doesn't have one canonical implementation. It actually has about 6 right now because they're easy to build at this point. So this interpreter is what are we on? 300 lines of code. So this is all those features. There's no type checker in this. So the interpretation is truly separated from the type checking. That's a design goal. The reason you can't annotate types is so you can actually run different type checkers. You could come up with linear types if you wanted to. You could add an effect for, say, the fix operator, so you could get rid of that and you could make total programs. You could then continue to use the same interpreter. You could run a different type checker with different guarantees. So this is everything that the language contains. Okay, these ones. And this was one of the original design goals. The EYG, eat your greens, the name comes from, if we're really strict up front, can we get some benefits later? And one of the kind of strictures was, what is the smallest useful set of making a functional programming language? So here we have the lambda calculus things, your var, lambda, apply, let. Vacant is a typed whole. Int and string are obviously we don't want piano numbers and stuff, let's just put those in. We have lists for a similar reason. This is everything to do with the records. So you have an empty record, you extend it, you put full a value, you overwrite a value. This is everything to do with unions. You tag a value, you switch on a case, or you have an unmatched case at the bottom. Your effect can either be performed, like lifted, or handled. And then we have built-ins, because you need to work with those literals. And despite the fact that I've listed these, I don't know, a dozen or so nodes, if we go through here, so this is the, so again, so an interpreter, I think we will not explain everything that goes along, but when you're interpreting through a language, you have the current value you're working from, the environment, which is all the variables you defined previously, so let A equals this, let B equals that, they keep in your environment, and then your stack is the instruction of things that you have remaining to do. So if you're working on calling a function, you first need to interpret the function, and then the arguments, and then the stack keeps track of the fact that you need to put them together afterwards. Everything in the language, apart from these 4, is first class. So you can follow an interpreter on making a CEK interpreter for the lambda calculus, and you'll get these first 4. Everything else is just modeled as a function. So even case statements are actually first class. So you can say let x equals case, and you'll get a function which accepts 3 arguments, which is the current branch, the otherwise case, and then the value you want to pass through. And this means that this is what drives the interpreter's simplicity so small. And actually, when you look at stuff in the editor, the syntactic sugar exists only in the editor. So different editors can make different syntactic sugar. This, I think, I'm assuming as everyone's quiet, they're understanding fully on this one. This one took me ages to get my head around. But yeah, so, okay. So, all right, let's go, what have I talked about? I talked 35 minutes. Sorry, that might be longer. So, that's I think that's everything I want to just like share with you while I monologue up front. I just kind of want to revisit like why I think these are useful. Like I think why I think this is a valuable subset. I think this rumor of functional programming being more productive for writing programs is fairly well proven. Like predictability is no bad thing. Reducing global mutable state is a good thing. Having immutable values. In any situation where you don't need to like talk to drivers, worry about memory, we're talking in the case that your computer is not at its limits, then the productivity wins. So then a lot of the functional guarantees have kind of shown themselves to be useful. But I think at this point, with a lot of functional programming languages, you start hitting the edges. So FFI is one big problem when you write in functional languages. So if you want to write your program and you have your client and your server in functional languages, and you have a JSON API between them, a lot of the pain is serializing the JSON API. The same is for the database, and so on and so forth. So where EYG is trying to tackle this is the demo of essentially taking code and putting it elsewhere. To me, that's an example of extending the type boundaries. So the type boundaries go over more than one machine. They can be extended further. One of the other things I can sort of extend this through is to the database. You could try and compile this to SQL if you wanted to. One of the other choices which doesn't seem immediately like relevant to this, but which is very important, is the fact that I chose structural typing. So structural typing allows you to have the same meaning. So if any record has a field name, it's assumed to be the same. Okay, so there's no way in EYG to specify that a string is an email string. If you want to specify something as an email, you'll have to make a record which has the field domain and the field like whatever they call it, front of the email. So that's kind of one of the trade-offs. You don't get to model your domain in that way. But the benefit of structural typing everywhere, I've got a lot of mileage out of it, and so I'm kind of bullish that this will be at least interesting. The fact that I've started replacing some of my bash scripts with, so I use the node runner locally, so I have node scripts, but my node scripts are now kind of type safe over build and the deployment artifact. That's a fascinating kind of superpower that, that would be my sales pitch of like, give it a go. It's very interesting. So that's it. That's my tour through EYG and the inside of what's going on in my head. Now, do we have any questions?
First, thank you very much.
Thank you.
Now, questions. Do you have a question? I'm running with the mic.
I want to ask you a simple question. What inspired you to build it? And how do you see it in like 5 years' time evolving?
So the question, you can hear the question. So what inspired me to build it was I kind of started seeing this possibility in a few places that you could have multiple representations. So the first language I ever programmed in was actually LabVIEW, which is a visual drag and drop thing for laboratory equipment. And I was intrigued by the idea that you could have more than one representation of a program to show to different people. So you could have a tool which was a visual code builder. And you could then switch to the text view, and your programmers could contribute to it. So the kind of classic problem where you have a no-code tool, and if you get a developer to help you, they say, first, we must throw this away and rewrite it in Python. That was actually the experiment for starting it. What became apparent as I went through this was the really small AST. I only saw it as valuable for having more than one front end, but it's actually valuable for having more than one back end. So the ability that you can bring your own type checker, it sounds like it sounds kind of frivolous and like why would you do that? But that freedom, I think, is going to be really important for having different backends where you might want to say bring in linear types and say that okay, this is a normal feature, but in this situation you can't use the fix, you can't have recursion because we want to get rid of it. It's no different a user experience as long as the type system gives it to you as saying you can't use the database effect on the front end. So one of the things I got this language to do last year was I actually compiled it to Go, and then I used TinyGo to run it on Arduino. So I've got a highly functional structured language running on Arduino. And the demo was I had a type-safe shell script which was building the server. Then I was passing stuff through just scope into a server that was then serving a page. That page was then using the web USB API, which was another effect, to then upload code onto the Arduino. So I was able to pass continuations from essentially shell via a server through a browser to a device. And so I think in 5 years, what I want to explore is those kind of unusual devices where they're small, so like getting a functional programming language is not useful on the individual device because it's too small a boundary. Like all of your problem is going to be deserializing and reserializing the communication protocols and start trying to abstract away the communication protocols. And then being able to like plug together the compilers so that you can really focus on going, okay, this one has a big garbage collector and this one uses one of the more like modern algorithms for like reference counting, and we put it onto an Arduino and it's the same program. Like that's where I would think in 5 years it could go. Yeah.
Any more questions? We have more. I'll start up here.
Thank you very much for the talk and new language. And the first statement, it sounds like a quite bold goal, building software that runs forever, especially when we have Erlang, Elixir, etc. What exactly it does for running software forever, or what are the problems in the current languages you see that are not allowing us to run it forever?
So the run forever statement. So I mentioned, so the effect, you can, when an effect is raised, for example, you can say, the effect is to shoot the missiles, kind of thing. The whole program state is serialized at that point. So the programs essentially never crash because you can always resume them later. So you can put them to disk. You can even write them on a stone tablet and pick up the program later. So the programs don't have the concept of being not like rerunnable anymore. And because you have a hash reference into the AST, there's no way for dependencies to kind of come around like after you. So if you have an artifact, if you have a big blob of source code, you can run a type checker, see what effects it needs to have. If the effect is I just need to log. Okay, it just needs to raise a string and returns a unit. As soon as you've taken your 300-line interpreter and implemented just that effect, you're able to like put it into other hardware. So that's kind of, well, there's more to this. There's these movements now for like local first software where you own your own software. Like you should be able to, if the service goes away, that continues running locally. But that's only going to work for the life of the browser that you got the offline web app from, or the duration for which your like native app works on the hardware that you have under you, and to move that like offline first app to a new piece of hardware, you're going to at some point have to emulate what your laptop looked like when you signed up to that service. Whereas with this, you can go, no, it only uses these effects, and if they provide in this form, we can run them forever. One of the other tricks which I have, so maybe I should kind of do a plug on like. Let's have a new tab. UK/log. Okay, so this has been a kind of an experimental project of mine for a long time. So I've done things here. So this is, you don't need this. I have a voice assistant called Colin, if you want to allow the microphone here in the web page, but we don't want that now. And so the run forever, because the types are structural and they can run in two places, you can actually type check hot code reloading. You can, that's a thing that I have demonstrated with a very carefully held together construction, where like the previous program. But you can have essentially two parts when you put them onto your, into your device. You have your handle function and your current state. And because you can type check the two independently, and the semantics mean the same, there's nothing tied by like the names. If you replace one of the handle functions, but it still accepts the same state, that's how you type check that you can actually upgrade your code. So I would love to do this like in the beam. I currently don't have a like compiled to Erlang target because I enjoy doing the browser things. But actually, you should be able to have a situation where you reference your running node, your editor has a deploy effect. The type of that deploy effect is correctly type checking with the running cluster. And so if your program type checks, you can hot code upgrade and guarantee that it'll never crash, which would be that would be quite valuable at that point. Like, that would be, I mean, I think this is where the EYG thing really structures. Like, you would have to jump through some hoops, you have to give up some things, but that is the promise that, like, if you hold it together, you get to that point. Cool.
Next.
Yes, yeah. Thank you for showing EYG. It was really really cool language. Lots of interesting innovations. I was just wondering with the closure serialization, like how deep does the rabbit hole go, so to speak? When you showed that it serialized some, like it can serialize functions.
Yep.
But where does it sort of bottom out? Like when does it stop?
It can serialize everything. You can take, for example, the resume function is kept efficiently as a subsection of the stack. And when you pass that through the serialization function, it takes that resume stack, turns it back into a lambda, and then serializes it. So any value can be serialized. The one thing that's interesting is, so running on JavaScript, I have to treat the async effect separately because await, JavaScript suffers with function coloring. So if your value that you're serializing has promises, then you need to have a promise serialization function. But yeah, every value can be serialized. There's no nominal references to everything, so there are some caveats like to this. Well, there's not caveats to the serialization. The serialization is complete and not actually that too tricky to implement. The thing that's tricky is what you've given up. So I don't have a type to represent, say, file descriptor, because you can't serialize a reference to that. So your programs have to, say, have a read file or open file descriptor effect, and then you have to have kind of a UID that represents the file on your machine. So if you send that UID, it would serialize, but it wouldn't be useful to anyone on the other side. So that's a kind of subtlety around it.
Yeah, thank you.
Cool.
Thanks. Cool. Any more questions? No?
No.
I have a final question. Any more people using this? EYG?
Any more people using this? Someone did message me on Monday with a wild selection of questions, which show you they definitely set it up, and they were like, because I still like oh yeah, I suppose I never did any sort of about me. So the slides that we have here were slightly shaky because I was laid off on Friday, so I don't have I work for anyone, and was starting them from scratch. There should be a much better round of documentation very soon, but this guy was going through the source code to find out all the key presses for the editors. So he was definitely trying. Yeah.
Cool. Yeah. Where can people find it?
So the website is there's EYG.run is where I have everything, and I don't do much on Discord or Twitter or anything like this. So I have an ad hoc. There's only been one email ever mailing list if people want to find out when it's in a slightly more approachable state. But go for it. I'm keen for people to try it out.
Okay, then thank you very much, Peter. Or more questions? No? Ah, one more.
Can I get one more?
Yeah, sure.
Yes, I'm actually like a front-end developer student.
Okay.
I'm still new for everything. So I wonder what advice you would give for a developer who wants to switch or transform from our traditional languages to YGI. And I wrote something here. And one might said shift we should have if we want to transfer.
I think that's an interesting question. Because there's a variety of things like, do you want to be employable in lots of places, or do you want to? I mean, I'm a big fan of keeping experiments going. There's a bit of an open question of how much of your free time you should spend on this. But I think if you're going to try something new, it should be really, really new, sort of thing. Like every once in a while, it's. I'm a big fan of developers having their sort of Friday afternoon do stuff, because I say a lot of the time you don't want to be experimental on the production code. You need to work out how to be boring in production. And boring doesn't mean conservative. I think if you find, like I mentioned, I use Glean quite a lot before. It's very useful in some places, so you have to kind of be open to throwing stuff away. I think there's what's the quote? No one ever got fired for picking Java is very true, but do you want to be that person? You will eventually be dealing with crusty systems. So I think just making space to put experiments in, this is wild, but if you're a student and you work for the next 40 years, I don't know, maybe I've given you a 5-year peak, or maybe I haven't. But you probably learned something either way. So have a go.
Well, thank you then. Thank you very much, Peter.
Cheers. Thank you, everyone.
Yeah. And thank you everyone for joining today, and thanks on the live stream. Again, we'll see you next time in November. Bye.
Cheers.
Cheers.